Hi folks, welcome to Math with Captain Rod. Making this video here to help you learn how to graph polynomial functions. So we're going to take a look at this animal right here. Y equals x cubed plus x squared minus 4x minus 4. So before we do anything else, let's talk about what I always call the long-term behavior of the function here. And I'll just draw this over here, kind of an x, y, not even going to put a scale on it. The highest power term is this one right here, x to the third. So basically what that means is when x gets very large, this function is approximately equal to x to the third. X to the third has this type of behavior. So what that means is, in the middle region here, there's detail to fill in, but ultimately this function has to end up going this way and this way, something like that. All right, now some points here. Zeros are a great thing to have when you're trying to graph. So I'm going to rewrite this. Y equals, and again, f of x and y are the same thing. Let's see if we can factor this. So notice that there's an x squared common to both of these terms. So this would be x to the third, and then this would be the plus x squared. And then when we look over here, there's a negative 4 common to both terms. And when we factor, I believe that's what we're going to get. And always check, when we do this product, there's your negative 4x, and when we do this product, there's your negative 4. All right, now notice that x squared plus 1 is common to both terms, so that can be factored out. I'm sorry, I don't think I said that right. X plus 1 is common to both terms, so can be factored out, and then we're left with x squared minus 4. And lastly, x squared minus 4 factors into x minus 2, x plus 2. Okay, so here are our zeros. X equals minus 1 is a 0. X equals 2 is a 0. X equals negative 2, also a 0. Now let's discuss multiplicities. Each of these terms, there's no powers on them, and that means these are multiplicity 1, and that's important. That means that when you go through negative 1 here, that means the function is going to break through the negative 1 either this way or maybe something like this. Remember that odd multiplicities, the function will change sign, as opposed to an even multiplicity. For example, just to go through this quick, had this been a square, that would mean this function would be doing something, something like this. But it's not. All right, so multiplicity 1 on all of them. So let's go ahead and plot these. Let's see. I've already modified this graph here because I've taken a look at this example ahead of time to make it look a little bit more appropriate here. So these little guys are going to be a quarter. So like this is the point 1, 0, 2, 0. So while I'm at it, 2, 0. Let's see. Negative 2, 0. Negative 1, 0. All right, let's get another important point here. The y-axis here is typically with a polynomial pretty easy to get. The y-intercept. If x is equal to 0, y is equal to, now look at our original function up here, putting zeros here, here, and here. And it's pretty easy to see that y is negative 4. So there's our y-intercept. So 0, 1, 2, 3, 4. It's about here. Okay, so we got a pretty good start at this. Now let's go ahead and plot a couple of points here. So when we look at, we know that these are zeros. So one possibility is maybe this graph does something like this, or possibly something like this. And we can tell which by calculating a function value. So I've already done that below. If you take a look at f of negative 1.5, and that means to put negative 1.5 in, you can actually put it in anywhere in here. When I did this, I ran it through here. I got 0.875 out of it. So negative 1.5, here's 1. 0.875 is like about here. All right, now we're really starting to take shape here. So this thing's got to look something like this. I'm going to stop drawing for now. Oh, and I just noticed that I got to go back here. See that 0 I put in there? I put that in the wrong place. That was supposed to be negative 4. case you're probably wondering, did he do that on purpose? Well, we'll go ahead and say yes, but no, that one was supposed to be down here. 1, 2, 3, 4. Sorry about that. I'm going to just erase that there. Now, this thing definitely is coming down something like this. Now, halfway between the -1 and the 2 is, what did I run here? I took a look at 1.5. Forget why I did that, but let's see, 1.5 is -4.3 something. This thing goes down, you know, a tad further back up. And I'm just going to sketch the rest. Remember our long-term behavior. Something like this and this. Let me redraw that a little better. Probably more like this. And again, to fill in detail, you can get some more detail just by plotting more points, but that's good enough. So our function here, again, it's a third order function. Long-term behavior looks something like this. The key to sketching these polynomials is find the zeros if you can. In a lot of these algebra problems, it's typically by factoring. Take note of their multiplicity. Again, that can be very important because when a zero is an odd multiplicity, that means the function will break through the point just like this. If it's an even multiplicity, it'll do something like this instead, and that's important knowledge for graphing it. The Y-intercept is typically a pretty easy point to get with a polynomial. Just make sure you put it in the right place. And then you can typically start sketching them. Usually you want to go between the zeros, like here and here. I probably should have picked a point a little bit more to the left, but that's okay. To figure out where these kind of points where it turns around are. I did not do that exactly the way I should have here for this turning point, but I'm just going to call it close enough for this video. Once you have those points, just sketch the rest using your long-term behavior. Anyway, again, the point of this video is how to sketch polynomial functions. I hope that this has helped out with that. Have a great day.